Everything is not. Okay. Good evening, everyone. So today's lecture will be a little bit of off rail from the regular lecture schedule. So sorry, it's not available. So we'll discuss about one of the major application of like one of the major area in NLP, that is we call as ethical NLP or responsible NLP. So responsible under responsible NLP, there are many sub problems like social bias detection, hallucination, jailbreaking. Many other problems are there, but today we will only focus on the bias detection, mitigation, and what are the related metrics that will help us to kind of quantify how much bias the language model has towards what are other like kind of demographics. So we'll discuss about all these things, all these technical terms, demographics, bias, all these things going on. So I was just going through whatever the contents are as covered till now. So it's basically like kind of pre-transformer era, like kind of things are there. Whatever that has been covered till now in the class, and last class I think NMT was neural machine translation was being covered. So I have kept one application for machine translation in terms of like kind of bias detection and mitigation. How do we do in machine translation? Rest will go over like in generic bias detection and mitigation general approaches. But because of time constraint, I might not cover all the recent detection methods or mitigations or metrics, but I will give pointers to them. Okay. So feel free to pause me if you have any doubt in between. Okay. What is- Yeah. So before going ahead, so because like there will be to motivate different sub problems, I might need to give you many examples, but the examples might contain some group reference to some particular like kind of demographic groups, but that's we cannot avoid them. So we have to adjust that. So this will be our flow of the lecture today. We'll start with bias fundamentals. Then what's the like how we understand bias in large language models or language models in general. Then some recent methods for bias detection, some mitigation, and something called bias benchmarking dataset. I will tell you why we need benchmarking dataset. Then case study of machine translation, as I mentioned. So before going ahead, uh, so this was one study done by a few researchers back in 1960s actually. So it was reported a lot later in the research domain, but this was a research done back in 1960s. What the researchers did, they gave kind of please be silent, guys. Guys, please be silent. Okay, so what researchers did, like they gave a series of paired words to kind of users, and these words they chose carefully in a way that either of the word can be used in the same context. Giggle and laugh are same meaning. They can be used in the same context. And what they asked the user, out of these two words, which word will be more likely to be used by females? Can anyone tell me? Out of giggle and laugh, if they are used or can be used in the same context, which word can be most likely be used by female users? Giggle, yeah. So there is another example. Let's say okay and nice. If both of these words can be used in the similar context, what a female user can choose. Generally, the female users choose a nice one. And also another kind of disclaimer before I go ahead with the lecture. If any one of you have attended my previous tutorials, the content will be almost similar, but yeah, I have not changed any content. But if you have attended, maybe you can ask good questions. Yeah. So next question there, that was kind of trying to tackle or kind of measure kind of gender bias through like the word uses. Next is for age bias. So if these two words are given, impressive and amazing, and which word out of these two words can be used more often by older person? Anyone? If they are can be used in the similar context, impressive and amazing. Okay, so impressive. Yeah. So this why we are able to kind of predict these things, because based on these gender groups or age groups, we have our own preference of using some particular words, even if they have similar meaning. There are many synonymous words, but we prefer to use some particular set of words based on our like kind of age group or gender group or religion group or race group or whatever, all these things. These are something called cognitive biases. These cognitive biases generally develop through because of our upbringing or because of our like kind of surroundings, many things like kind of act as a reason for this cognitive biases. So what happens? So because of this, what the language models and these LLMs, they are trained on the data that is being generated by us indirectly, right? They are trained on this web scale data. Those web scale data are being created by us. And if we are kind of biasing them through our own cognitive biases by the use of these words or by use of particular kind of sentiment bearing words or kind of use of sentiment use of some particular sentiment bearing scenarios, obviously language model will learn those cognitive biases. So those cognitive bias in turn act as inductive bias for the language models. So again, what is inductive bias? I told you briefly what is cognitive bias. Inductive bias is like we have defined a structure for a model. Like we have defined, okay, encoder-based models will follow bidirectional structure. They will look before the current word, look ahead of the current word. Unidirectional model, they will only look before the current word. So that structure that we enforce, that is called inductive bias. So indirectly through these biased context or biased sentences, what we tell the model, you follow this inductive bias in the context that I am giving. So in the context of, let's say, this okay and nice or laugh and giggle, if the context is female oriented, I'm telling more often use giggle. So model will only generate giggle word if says, okay, this is a female speaker. Both laugh and giggle is possible. Model will generate only giggle, but because it has seen that inductive bias through the pre-training data. So that's what happens when we say model is biased. So majorly we can attribute model is biased because of the data set that we are providing for the pre-training. But is that like end of story? Because data is biased, we cannot do anything? That's not. So we can do many things actually, like how do we kind of detect how much bias is there? How do we come up with some approaches to kind of tackle these biased behaviors of these language models, and how do we do that? So that's like kind of the main crux of this research area. So what is cognitive bias like by definition, how it goes? So yeah, if you have, I believe you, some of you might be like kind of fond of reading novels and all. So if you have read this Thinking Fast and Slow novel, so there is this concept of how do we make decisions. There are two systems of decision making by human being. That is one system one and system two. System one is like kind of automatic system. We take decisions very fast, and we don't take much logical decisions. We make decisions that are effortless, and we don't try to link so many things to like kind of come up with a final solution. But system two is slow system, and we try to make more logical decisions. So there is a big question in the research field, like in the research community, which system is more biased, system one or system two? Some people can say that system two is also biased because we think a lot about a problem, or like before taking some decision, we think a lot about that particular problem. We might become more biased in a way that, okay, which one to prefer or not. System one sometimes will not like kind of allow us to think more. So like we may not be biased. But system one is generally believed to be more biased because there we don't think much and we make decision based on our own cognitive bias. So the biases we see in the system one and system two are very like very much different in subtle way. System one is also biased in a way that we make decision based on our own cognitive bias because we don't we don't rely on like kind of consequences, all these things. System two, we rely on consequences, what consequences we might face after making decision. So based on that consequences, condition on that consequences, our decision can be also biased there. So either of the system can be biased, but majorly in the community, we believe system one is more biased, and we want to tackle these kind of problems like the biases that arises due to system one. So this is just for your reference. You can go back and check like kind of possible categorizations of cognitive biases. I am not going to deeply into each categories. So now we understood like what is cognitive bias, like how do we recognize these biases in language technologies? Before language technologies, so this there was a method called implicit association test that was that was developed back in 1998, sorry, to kind of measure biases of like US users, particularly US cohort, to how they differentiate black people and white people. So this was not just on words, this was also based on images, so combination of words and images. So what they did, they gave shown users like kind of set of African American faces and set of European American faces, and the two set of words like good words and bad words. So what this implicit association test try to measure is like the user is sitting in front of a computer, and either a African face will come up on the screen or a European American face will come up the screen. So you can easily distinguish. So one is like black face, dark skin person's face is coming. One is like kind of fair skin person's face is coming on the screen. And you have two pairs. Either you have to choose this like this face belongs to white or bad group, black or good group, or black or bad group, or white or good group. So if you see clearly here, this I don't know if my pointer is visible. I don't think the pointer is visible. I will use this pointer. One second. Yeah, so if you see here, white and bad and black and good here, there is some incongruity, right? Like generally, based on our like cognitive bias, we don't associate white with bad and black with good. But based on our cognitive bias, we associate black with bad and white with good. So that's what they are measuring. So you have to respond with two buttons. This face belongs to which group? So what they observe, if the like in general, there are two questions they were measuring. In the first question, they were measuring if people are quickly responding to this kind of scenario where there is incongruity, or whether there is people are responding quickly to this scenario. So what they observe, people are responding quickly to this scenario when there is no incongruent, like the cognitive bias is there in the association, black with bad and white with good. So now the question is which group they are associating with, like which face they are associating with which group. So what again they did the second experiment. They saw people are responding quickly for fair skin person to white and good, and dark skin person to black and bad. So these are the two research questions they are kind of trying to tackle through this implicit association test. People are responding quickly when there is this cognitive bias groups association is there, and so how they are associating fair with white and good and dark with black and bad. Right. So this was their kind of scenario how to measure this implicit association test through user study. So people then same group extended that to earlier they did with like face images. They extended it with two words. So they asked like this is the word we have shown to you, whether you associate with European American good or African American bad, and they wanted to see the positive words are being associated to which group by the users. So this was the kind of idea behind the implicit association test. So what happened? People kind of exploited this test going ahead in a like kind of intelligent way to come up with metrics to measure biases in like this language model scenario. So I'll come to that. But before going to that, when we say we are associating this African American with bad words or European American with good words, there is some bias. So what exactly the bias definition, how exactly the definition of bias goes? We discuss something called cognitive bias that is based on our decision making. Now we're going deep dive into like kind of biases in NLP systems. So let's understand how do we define the biases in NLP system? Then we'll kind of link to this metric, how we'll, based on that definition, how we'll come up with a metric using this implicit association test. So what is bias? So bias, if you like from our like kind of elementary mathematics, we know we are given this equation of line y equal to mx plus b. B is the bias term we generally call. What is this? B is the difference between prediction and the true values. Right. This is the kind of one kind of bias we know from the statistical statistics and like kind of mathematics. The second bias we know is from the Bayesian framework. When we say posterior equal to likelihood into prior by a total probability, and the prior is generally called as the bias towards that particular class. So this is the second kind of bias we know in the mathematical domain. But the kind of bias we are concerned is a little bit of off-rail from the mathematics, that is bias in the social context. So the definition of this bias goes like this: like it's a preference towards or against particular individual or group based on their social identity. What are the possible social identities? Like can be race, gender, religion, age, etc. Right. So why it happens generally? Again, it's because of our system one decision making. Because we try to take decisions based on our own cognitive bias, and that gets affected by our upbringing, and that indirectly affects the decision making, making it more biased. And it's also individual preference. So individual preference is for definition to say it is individual preference, but this individual preference also indirectly, if we create a causal graph, it gets indirectly affected by many more things, like from our surroundings, from whatever we have read, whatever we have heard, all these things. It's not just an individual preference, but causal graphs makes it more concrete, saying it is not just individual preference, but it is based on the society we're living with. But this bias can be either positive or negative. So when we say biases are not always negative. They have also positive connotation to it sometimes. So let's say I prefer, let's say, cricket. I'm much more biased towards say one particular cricketer, whatever he does. I'll say okay, that was a bad ball, but that was a very good ball. He could not play, or that was a bad pitch. He could not play, because I'm biased towards that particular batsman. I'm saying okay, he's very good even if he didn't play good. Right? So that's a positive bias I'm making towards the person. So the example is, if you are hiring a Asian for the job that has an equally qualified black applicant, why the employer did that? Because the employer has the own cognitive bias. Asians are more smart than black applicant, even if based on other attributes in the application, it was completely exactly same, but they prefer the Asian person because they have their own cognitive bias. Similar scenario happened when like kind of Amazon or Microsoft released one tool for like kind of job application filtering. They are making more biased decision against women applicants, making like rejecting their applications even if the applications were equally qualified with many of the male applicants. So we saw like bias can have more positive and negative connotation. So our point is, which kind of biases we should focus on majorly in terms of our NLP setup, NLP pipeline, NLP life cycle. Which kind of biases we should focus on? So this is a famous talk from Kate Crawford. Like if you are interested in this domain of responsible, I would like kind of request you to watch this like kind of this is 47-minute or 50-minute tutorial session by Kate Crawford in New Year's 2017. So she nicely portrays like where we should focus on in terms of our like ethical AI research. So the famous quote from her is, "Bias is a skew that creates harm." So we should focus on the biases that has potential to create harm. So there are potentially some positive biases that can also create harm. Like because if you're making some biased decision being positive towards one group, other groups might get offended also, and they can create some chaos. Right. So it's not like always we have to tackle only negative biases or only positive biases. We have to see the consequences of the bias. So if the consequences of the bias is harmful, then that's the kind of sub problem we have to tackle. So what are the two major harmful biases? One is allocational harm, another is representational harm. So representational harm generally happens because of the representation space of the language models. Like when we talk about these LLMs, So we trained the language model. We deploy the language model to make some decisions or generate some long text, right? So there was a when GPT-2 was released, there was a famous paper. You just kind of prompt GPT-2 with the word Muslim. It used to 100 out of the 100 times. It used to generate negative kind of context till if they are generating till 100 words, just based on the prompt Muslim, nothing else. So that's kind of the representation harm like can happen if the language model's representation space is biased towards particular group. Allocational harm. So if the representation space is biased and you are using those language models to make some decisions like binary decisions or kind of multi-array decisions, like scenarios are a hiring solution, college admission or loan application. So there also these harms can affect personal lives of day-to-day, lives of many people. Like so, these are the two major problems we want to tackle. But the main problem is this representational harm in terms of our language model space. If we are able to handle this problem, the representational harm space, then allocational harm will get automatically handled. But there are also kind of works like even if the representation space is harmful, if the representations are biased, we can come up with more innovative solutions using biased representational context. We can create the unbiased allocational scenarios, right? So that's why there are two problems. So we could have easily told, okay, there is a major, we only want to tackle the representation space, but that's not the only way, because when we're training these large language models, we have to scrape data from web scale, right? And filtering those data and making those data unbiased is humanly, or maybe it's not even possible at all. So representational space always making it unbiased or neutral towards every category, every subcategory is like not feasible. It's like kind of we're trying to tackle something that even cannot be tackled for 1,000 years. So then we have to think of some techniques to kind of tackle the allocational harms, conditioning on the fact that we cannot make the representational space of the language models completely on neutral or unbiased. Yeah, so now coming to some scenarios where these biases can be observed in language models. I don't know if this image, I believe these are visible to you. So here if you see, nowadays these large language models are being used for like generating codes also, programs or something like that. So these are two scenarios where like large language models were prompted to generate codes. Like first scenario, the left side image shows we were trying to generate some Python code, and right side is like kind of ASCII code, something like that. So if you see, we didn't give any particular biased prompt. We just asked based on age, sex, ethnicity, nationality of the person, whether decide whether the person should be tortured or not. What was the response from ChatGPT? This was, I believe, ChatGPT 3, not 3.5. It was like last year's output. Now, if you try to generate, maybe the response will be something else. So what it said, if you particularly focus on this second and third if condition, if ethnicity is Caucasian and nationality American, return false, meaning don't torture them. So that's a clear preference towards like kind of this white racial group. And second is if sex is female, return false. Also like indirectly saying if there are two possible culprits. If one is from male gender, one is female gender, model will prefer always the male gender without knowing the context. So the right hand scenario is like in kind of a intersectional scenario. You have to based like for intellectual parameter based on race and gender, kind of rank from first to last. And model, if you see, like clearly biased towards the white people and a male group, and it's like kind of negatively biased towards other racial groups and gender groups. Right. So if you see like where these biases occur in the overall pipeline of these language models, if you divide the NLP into two systems, one is like kind of training scenario, one is database data set. So biases can occur in the dataset setup, like the dataset we are using from the using for the training, and during training also, the because of the algorithm, because of the loss function, or because of the architecture design we're preparing, there also it can come. So when we are talking about the bias in data, generally it's of two types: descriptive bias and stylistic bias. So what is stylistic bias? We'll discuss about the stylistic bias when we discuss the use case of machine translation. Then in previous slide, we saw one scenario of primary bias, like bias towards a particular group, or intersectional bias, bias towards intersection of multiple groups. So what are those groups? They can be something like this: gender, race, ethnicity, etc. Yeah, so for timing, I skip this. The main point of this slide is, so when we say, okay, data is biased, that's why models are biased, but that's not the end of story. Even if the data is unbiased, models can be biased, and even if the model data is biased with x to y ratio, models can be biased with x minus z and is to y plus z. So those bias ratio can also change. So what happens when we train the models? Something called bias amplification happens. So that's we'll discuss about it more in future slides. Maybe I'll just keep for this. So when we again coming to bias in data, or how the bias in data can come, because majorly because of the data distribution, where from which region, which time period, and which kind of cultural context we are sampling the data for pre-training, and who are the annotators. Let's say the data are like kind of coming from African cultural context, but the annotators are Indian or American. They would not understand well about the African cultural context, because why that is happening? Because in African culture or Australian culture, there are not much annotators, or South American culture, there are not much annotators. Annotators are majorly like kind of populated around North America, Europe, or Asia. So, because if you annotators are coming from these three regions, and we are making some decision towards African cohort or Australian cohort, obviously annotations will not be culturally nuanced. When I say culturally nuanced, so this example clearly shows what do you mean by culturally nuanced. This is something called semantic role labeling task kind of thing. So there is a image, there is an image, and you have to detect what are the events happening, what are the entities present in this image. So if you see this for the first two images, the entities predicted by the sorry, annotated, not predicted, annotated by the annotators are perfectly fine. For the last image, the same label should be there for the last image also, because this is on our marriage ceremony for African culture. But annotators didn't have any idea about this. This can be a scenario for marriage ceremony in African culture. So they just mentioned this is personal people. So if you train models based on this kind of data, and model will not understand what is the culture of marriage in Africa. So they would obviously make biased decisions against that, right? So that's how bias to the language models creep in because of annotation, and also because of biased languages. So what do you mean by biased languages? So that I mentioned in the initial 2-3 examples, right? Generally, a particular demographic group prefer to use particular kind of languages. So because of that, also like the systems become more and more biased. Yeah, so this is what I was describing, kind of the distribution of the annotators around the world. If you see, it's majorly kind of populated around North America, Europe, and Asia, but that affects the decisions of other regions. Yeah, so coming to the scenario of bias amplification. So how bias amplification can happen? Just one visualization. This is also output of a research work. It's not someone is making it up. So this is a task of visual role labeling, visual semantic role labeling. So what's the goal of this task? So given an image, you have to predict all these things, like who is the agent here, what's the food being shown in this image, what's the container, what are the tools. So you have to predict these four roles for given image, right? So if you see here, what kind of biases they wanted to measure here is the particular gender bias. This is a classic scenario for like kind of measuring bias when the context is cooking, And we know the inherent stereotype is like women are like choose to be with the person who cook, and men are not, right? So whether language models observe kind of behave in the similar way. So what they did in the training data, they had this kind of distribution. 33% of male person cooking, and like through the images they shown to the model. 33% of the cohort are female cohort and they are cooking. Clearly, it is visible from the image they are the male cohort, and 66% of the cohort like the training data had a female person cooking. When they tested the scenario, or they tested the model on a balanced distribution, the test data had 50% of male person cooking and 50%, 84, sorry, 50% of female person cooking. But model's performance was 16% for the male and 84% for the female. So why it happened? Because even if there was biased ratio for 32 to 60 in the training data, during a training because of loss function or something, model kind of amplified the bias. So ideal scenario was at least model will replicate this bias, and that in test set it will behave like 33% accurately for male and 66% accurately for female. But now model is much more biased, making many more of false positive predictions for female group. So this is how like model can bias. It's not just because of the data. There are many other research works, they prove the same concept. So in the overall NLP pipeline, so we one entity we saw is like data. Because of data, model can be biased. Other things are like because of the model architecture that the work I was discussing, they were kind of trying to extract what is the religion bias in the GPT-2. So there they like kind of clearly mention how architecture can be one of the major reason for this biased decision of the language models. Other thing is decoding methods. So nowadays we are using these beam search or top K, top P decoding methods. So those decoding methods are also not like kind of bias free. So why they are the reasons behind bias and hallucination also. These decoding methods are kind of major reasons for hallucination also, because we are choosing the top probable tokens given some n-1 context. That's the objective of language modeling, right? So when we are choosing only top probable tokens, those top probable tokens will come because of the inductive bias of the language model that it has learned from the data. And data we are giving, that is biased data. So if the decoding method always chooses the top probable tokens, it will of course choose either hallucinated tokens or the biased tokens. So we have to come up with some innovative decoding methods that can be maybe some decoding methods regularized by some demographic group, something like that, that will control the biasness of the language model generation. And the evaluation scenario. So evaluation also, let's say the fine tuning data was based on African American text, but you are evaluating that model, like you fine tune the model on African American text, but you are evaluating that model on European American text. So obviously model will not do well on the European American test. And also the deployment system. There was a classic example I gave, like a model that was used for detecting recidivism. The model was trained on US cohort, but the Delhi police tried to use it in the their scenario to detect recidivism. And the model's performance on the Delhi cohort was just 2%, even if that was performing very well on the US cohort. So it's like you trained on one particular kind of cultural data, you cannot use it on completely different cultural data. Yeah, so again, I'll just skip this slide. So this is again the definition of the bias. Yeah, so coming to kind of formalized definition of bias. So when we say bias, as I mentioned, uh, it's like a little bit much more nuanced. We cannot say something bias without saying these 5 components for the bias. What do we mean by that? When we say some particular sentence or some particular image or some particular scenario is biased, that should have these 5 components. Meaning, who is the communicator? Who is like kind of showing this image? Who is the creator of the image, or who is the creator of this text? When we say who is the creator of this kind of instance like text or image, we're majorly concerned about the person's social demography. Also, who is the listener? So the scenario is like if you make some comments about some particular group in the North India, that may be completely problematic, but in South India that will be fine. So in the Indian context, that changes that frequently also. So always the communicator or listener is also important, like to understand the bias. It's not always biased because of the communicator. So whoever is listening, the person can take it negatively or positively. When I mentioned we have to discuss about harmful bias only. So this harmfulness can differ based on the listener. So some sentence can be completely normal for a particular group of listeners, but it can be biased for the particular other particular group of listeners. So then when we say it is biased, there should be a definitely target, like this biased post or instance is targeting towards which group or which subgroup. And what's the category? Category are those major categories like gender, race, religion, etc. And saying something is biased is meaningless without any reason. So we have to have some reason to say why this particular post or whatever the particular scenario is biased. So then only that's where the system to decision making will come. So if will not provide the particular reason why it is biased, then a model cannot make some decision based on system two. So they will always make decision based on like without this component R component, model will again make decision biased decision based on this just the group of speaker and group of listeners. So definitely we have to force the model to reason why you are saying this thing is biased, right? So that's why model will make more kind of nuanced decision or kind of decisions that is correct to say it is biased, right? So this is something we came up with in through our one of our work. Like if key like to define a bias, we definitely need to have these five components. The way we define like sentiments with quintuple definition. So bias should have this quintuple definition also. So without any of these components, we cannot define a bias. So this was like kind of initial work to show whatever the data set we should develop for bias detection should have all these components. Yeah. So now coming to another problem of in the like kind of area of ethical AI, that is stereotype. So if you say inherently, if you think about it, stereotypes are biases, right? Like when we say bias and stereotypes, they look like synonymous to each other, but there are subtle difference between stereotypes and bias. Stereotypes are generally some overgeneralized statements about some concept. But if I make that stereotype like based on the stereotype concept, I make some opinionated statement that becomes bias. So what I can tell, every stereotype is a bias, but every bias is not a stereotype. So that's the only subtle difference between bias and stereotype. So there are bias because of my own opinion, my own upbringing, I can create those biases, but those biases may not be stereotype because that's not overgeneralized belief. So to like kind of explain this, like there are three, if you see these three examples, some machines are good at maths. That's a existential fact. So this neither a bias nor a stereotype. But if I make a statement, all Asians are good at maths, that's a stereotype because I am like, it's like factually may not be possible, but because of my own stereotype or the stereotype of the society, I am making this statement. But if I make an opinionated statement by comparing with another group, like Asians are good at maths as compared to Americans, that becomes a bias. So the stereotype goes like Asians are good at maths and Americans are not good at maths, but I'm like kind of using these two stereotypes to make an opinionated statement. That is bias. So this is the formal definition of stereotype when the existential quantifier is overly generalized to the universal quantifier for that concept, it becomes a stereotype. Yeah, so the types of social bias and their definitions are kind of synonymous to the bias definition we saw earlier. Only thing is now it is like focused on that particular group only. Yeah, so I'll skip this slide. We have seen all these things. Yeah, so another important concept for this ethical domain is something called sensitivity. So we saw bias and stereotype, both can be positive and negative, and we discussed we are only focusing on the harmful biases. So the sensitivity is another subclass of those bias and stereotype that is always negative. So these kind of sentences, the post, they always have the negative connotation. They always have the negative connotation, and they have the potential to create some kind of aggression or chaos or something like that. So the kind of scenarios that is happening now in Bangladesh, like those are sensitive contexts. They're not just biased; they are much more problematic, and we can call them a sensitive posts. So in the this is some kind of new kind of classification or new domain that we only came up with, and people are currently using it. So we're focusing on biases and the stereotypes, and biases are majorly of two types. We're discussing biases in language models and data, but also when we're deploying these kind of language models in the scenarios of, let's say, news or data generation, or like kind of movie script generations, we have to focus on some important concepts like sensitivity. If we're generating some sensitive post through news or movie scripts, those news and movie scripts, like those firms, they might face like a lot of financial setback also, because they can never go public. So one example is church is a racket. I know how they are operating. So this is a biased statement, but this is not just biased. This is also sensitive. So this can create chaos like that. This can provoke a particular demographic group to create chaos. Right? So this is also one kind of niche research area we're focusing on. So why this work on the social bias is so much kind of gripping nowadays? This like started back in 2016, but it's nearly not solvable till now. Also, like with more and more language models coming, and the problems are becoming more and more tough. So why it is happening? Because the ever-growing socio-politico-economic context, like the social context is evolving, political context is evolving, economic context is evolving. The language model trend in 2020. They understand the particular political scenario in US or India. Now, if you deploy that model in recent days, they will not understand what's the exact bias, right? So you have to like kind of evolve these language models with the social context, evolving social context, and that's makes it more kind of complex for the language models to detect them. So one classic scenario is the use of word nigger in US. So back in 1500 or 1600, the word was fine if you use them in US context, but nowadays that creates chaos, right? Their socio-political scenario has evolved a lot, and they don't accept those facts. And in Indian context, women empowerment, of course, like earlier, if you go back a decade ago, that was maybe a concept. Okay, women sitting at home is fine, but nowadays it's not the same scenario. The social context has evolved a lot, right? So these are kind of more examples for that. So now coming to now we understood the kind of definition of biases and how they kind of how they are very much subtle in their use cases. Now we'll link it to the implicit association test that we observed, like kind of discussed earlier. So if in implicit association test, so this is 6:15. I think we should take 5 minutes break. That's the general uh, setup, right? So let's take some 5 minutes break. If you have any doubts, feel free to ask me now. Otherwise, we'll resume at, let's say, 6:20 or 21. If anyone has any doubt, feel free to ask. Some essence are good as bad. Generally, when you have existential quantifier, it will always, like 99% of the time, it will be factorial because it's existential. So if you ask quantification to it, there is a risk of saying whether it is factorial. And to check factuality, there are like this fact checking knowledge graphs. Again, they are also very much problematic in the sense that they are affected by the ever-growing social context, all these things. They have to also evolve in their own. So because there is time, I'll just announce one thing. So last year, part of NLP course only, one group they are interested to do one work on ethical NLP. So we started that work and that got published at NACL. So if you guys, any of your groups are interested to work on ethical NLP, you have nice problem statements, feel free to talk to me or Aditya is there floating attendance here. So we'll see if there is some potential. We can go for a paper also. So it's not you are not expected to do like kind of intense work part of your course project. You can do whatever is possible till course project. But if we feel there is a potential for publication, we'll continue that piece of work maybe 2 3 months beyond the course project and make it publishable. Okay, let's resume maybe. So now what we'll try to do, we a little bit fast pace the series of slides. We understood the basic definitions and nuances of this bias. Now, so what let's try to do is like relate the implicit association test to come up with a new metric that can be used for bias measurement. So if you know about this word embeddings like what to be globe, what's their beautiful use cases. They understand this context like man minus woman is king minus queen. So this you were like kind of fascinated by these embeddings are kind of able to understand these relations. They're particularly called as the analogy tasks. So these analogy tasks they are able to do well. But in turn, when the models were trained, what to make or globe, they learned some biased associations also. So the biased associations are man to surgeon, woman to nurse, or man to professor, woman to associate professor, man to programmer, and woman to homemaker. So in every examples here you will see here the women group is like kind of shown in a demeaning way, right? As compared to the male group. So that's kind of bias. This language model is also learned from the whatever the pre-training or the training, pre-training corpus and the training approach of the what to wake or glove. So this was observed in both in what to wake and glove. So the target was how do we measure how much these biases are there in the word embeddings and how much it is biased toward which particular group. Let's say one group can be sorry gender, one group can be race, or for racial group how much biased these models are, for gender group how much biased these models are. Right. So there they use the concept of this implicit association test. And there we had these four groups, right? Good, bad, and African American and European American. Synonymously, they created four groups here. They call this as word embedding association test. Earlier it was implicit association test. Here it is word embedding association test. So here we are only working with the like kind of NLP scenario, textual scenario. We don't have any images. Obviously, these tests have been like kind of extended to image also, but we'll focus only on the word embedding or sentence embedding association test. So we need four groups. One group is, let's say, synonymous to African American. We can have that male group. Synonymous to European American. We can have, let's say, a female group. So these are the social groups we are focusing on. And what are the attributes? So the terminology goes like this. So XY belongs to social groups and AB belongs to attributes. Which attributes we are focusing on? So in this example, if you see, we are focusing on these two attributes called, they are called stereotypical male professions, stereotypical female professions. So instead of these two groups, we can have other groups like, let's say, career related terms or family related terms or bad words or good words or violent words or like kind of non-violent words. So many things we can have. So that's depending on what we are trying to test, what kind of bias we are trying to test for the gender scenario. And we are considering only the binary gender here. And this word embedding association test can only be used for binary social group scenario. If we focus race as multi-array, like let's say Asian, African, American, all these things, there this word embedding association test will not work. We'll see which metric will work there. So what they did here, so if you see here, there are these two groups. I know. Okay. These two groups A and B, right? These are the attribute groups. You take a word from the group X or group Y. So you start with one particular group, and you see each word in the group X, whether it is close to word A or word B in the embedding space. You have the embedding for programmer, you have the embedding for nurse, you have the embedding for man. You see on average which words from X group closer to group A or group B. Similarly, you see similar behavior for the Y group. Now you use both the concepts and see what's the difference between association of X group with A and B compared to association of Y group with A and B. And if you kind of work out this mathematics, you will see the maximum value it can take is +2 and minimum value it can take is -2. What do we mean by when it takes positive value? Positive value shows that X is more biased than A and Y is more biased towards B. Negative value says X is more biased towards B and Y is more biased towards A. So we can like kind of shuffle these groups and in this group in terms of these group words, and we can have different groups to test different types of biases or towards different particular social groups with different attributes, right? So like this is kind of a homework for you to like kind of try out like if how it becomes the maximum value becomes +1, minimum value becomes -2. So as I mentioned, so this is one of the way they extended this implicit association test for the word embedding bias measurement. But this was working only for the binary bias groups. So there are like complexity for how do we extend this to multi-variant social groups. Then this mean average quotient similarity. This paper I have just cited because I cannot cover all the papers. So this paper they came up with approach how we extend this weight like the word embedding association test to multi-array scenario, and this is a very simple modification. So instead of kind of if you see this looks like something cross entropy loss some alpha -1 minus alpha something like that. You have to make it to kind of sigmoid kind of scenario instead of cross entropy scenario. So if you see like this a slight modification they have made to that formula to come up with the approach that can work for multi-array subgroups. And then this bot kind of models they come up with that are contextual. So here if you see this will only work with static embeddings because programmer in the context of male words will have same embedding, and in the context of female word will have same embedding because these are static word embeddings. So how will we measure for contextual embeddings? People came up with something called sentence embedding association test. In the sentence embedding association test, the measurement approach is exactly the same. Only this the kind of inputs we are giving as set X, set Y, or A or B that differs. So that's also not very tough for you to understand. So feel free to like kind of explore this paper also, how we can extend this word embedding association to sentence embedding association test. But if you think about the sentence embedding association test, that's a little bit problematic in the sense that piece of approach, that piece of metric has like kind of some design problems, and currently we are working on a kind of solution for that sentence embedding association test. Maybe we'll be publishing in very soon. So that I cannot share it right now, but maybe towards the end of this course we'll discuss about it. So now coming to, so this was kind of a quick overview of the metrics that are there majorly for bias detection, but there are much more like a lot of new metrics that have come up. So these metrics, they work for the embedding space only. You have the embeddings for different words of the sentence and you can measure the biases. But there are new metrics because now we're going to generative AI setup. In generative AI setup, when we are generating text, how can we measure bias directly on the fly? So those metrics I have not shared. Maybe if you are interested, feel free to ping me. I'll give you the reference to correct papers. So now looking at another scenario, how do we measure kind of detect bias in a particular task of head speech detection? Why I were more focused on why I'm focusing on head speech detection? Because if you see the kind of data set we have for the head speech detection, it's easy to intuitively think that this data set can have more bias. Like if we make some decision whether the instance has head speech or not, it's intuitively thinking these systems can fall into the problem of bias a lot. Because if you see the head speech data sets, many instances will have black words and it is annotated for being head speech. Right. Then if you train those models on those kind of data set, model will believe even if it is a black color because of those just black word, if it is not referring to the black color of as a skin tone of a device, model might give high probability for that sentence being head speech. So we are trying to detect head speech, but the models are biased towards these lexicons because of the nature of the problem itself. Because when we kind of annotate or collate data, one particular group of data will have will be annotated for more for head speech or other will not be. So if we train just on those data, model will be making biased decisions. So this is a famous model from Prospective API. This is currently also a state-of-art model for head speech detection. It's free available. You can try it out. So if you see here, these are two sentences: WhatsApp bro and WhatsApp nigga. So model gives completely like zero toxicity to the first sentence and very high toxicity to the second sentence because of just the word nigga. But this nigga word can be very common in African context, so they don't find it maybe problematic. So just saying a model, for a model to make decision based on sentence, it's unfair. So we have to have some cultural association to it to make correct decisions or unbiased decisions. So that's what one of the work did. What they did was they took two data sets and they tried to see how much biased the decisions are for head speech detection on those two data sets. And this was just for like kind of to report how much biased this kind of trained models are making for this head speech detection. And they saw that both of the data sets have like when you train the models on based on these data sets, they affect the models in a way that models will make biased decisions. And both of the classifiers were making biased decisions against African American tweets. So whether the African American tweets are offensive or abusive, whatever the classification is, models were going against the African American tweets because from the annotations, it has learned from those types. So if you remember in the bias in data, there was a third point, the kind of use of languages, right? The way the tweet is mentioned, they understand that there are tools to detect whether the tweet is African American or European American. So you can use those tools to measure on which kind of subgroup, African American tweet or European American tweet, your kind of classifier is working well or not. So they observed that African American tweets, the models are not kind of working well, like they're making more biased decisions. So this is kind of one of the way how do we kind of measure bias using particular task and particular data set. So there is not a specific metric for this. So you can take a particular task and a data set and measure how much bias it is, how much bias the data set or the trained model is based on their F1 score or accuracy. So we're not coming up with some weight kind of score here, just based on F1 score and accuracy. We can say attribute this biasness. So that they are this kind of scenario are called the detection bias detection through data set. So there are many other kind of works that have that has released kind of data sets to measure or detect bias. This is one of our work for detecting bias in Indian context using Hindi tweets. So this is like kind of 9,000 tweets we annotated for different bias levels using the quintuple definition we have created using that definition. So we released a data set to detect bias in Indian context for Hindi tweet. But that was not the major kind of contribution for this work. Major contribution for this work is like if you see the nature of this bias task, bias detection task, they are much more subjective. Like if I feel something is biased, somebody else may not feel that is biased, right? So that's why we call this as more subjective. And collecting such data set is a lot more complex than like data set of settlement classification or some other data set. So our target was, can we create a small sample of data set for a particular language or for a particular culture and perform at like kind of highest level using the data set of different cultures. So bias detection as a whole is a common task, but it will differ from culture to culture, language to language. Obviously, it will differ to understand the nuances. So that's what our task was. Like, can we learn the bias detection from English data or Italian data or French data or something like that? And if we train, we have a bunch of English data set that is annotated for whether for the presence of bias or not. We trained a model on that. We don't need to annotate Hindi data for like 9,000 instance. We can train collect let's say 1,000 instances and whether we are able to achieve similar performance or not. So that's what it is called FuSat multitask learning setup. And we saw it works well. So if you see this, particularly this middle curve, the blue line shows like the model trained on the Hindi language standalone. We are not training that model first on the English data, just on the Hindi data. So when it was trained on, let's say, zero data, like very few data, the model was performing as 33 F1, 30 F1 score. It is slowly grows. But when we start with a model that is already trained on the English data, it learns some nuances about the bias detection task as a whole from the embedding space, because we use this multilingual embedding XLM like XLM robota model. That's the embedding of this XLM robota are like kind of multilingual in nature, and because meaning if a sentence is in Hindi language and a similar sentence is in English language, their embeddings will be closer to each other in the embedding space. So obviously they understand some nuance about the bias detection and the embedding similarity of different languages. So we to start like kind of have a model with around 55 or 57% F1 score. We don't need to have any Hindi data at all. So without any Hindi bias detection data, also model can perform at around 57, 58 level. And also we saw like let's say if we are training standalone the model on Hindi data, whatever level we are performing, every time model trained on the English data outperforms that the standalone Hindi model. Right. So some even if it is very culture specific on task specific or language specific, some nuances about the overall bias detection task it learns from the data, and it is applicable to all the languages, also Korean language or Italian language. But if you see, there was a big gap in the Italian language because there is very closeness of Italian language with the English language. But that much closeness is not there in the Korean language family and English language family. So you have to understand the nuances of the different language families, Indo-Aryan language family, European language family. Then maybe you will understand these differences very well. So there is another piece of work we did. Again, the goal was to detect biases through data set. And the second goal was, as we saw here in this work, Because of the data set being biased, the models were making biased decisions. So how do we reduce this biased behavior of the models towards African American tweets? So this was kind of our goal through this task. So I have not elaborated because it will take some time to explain you. So you feel free to like explore this paper. Here we show like how using counterfactual, counter narrative data augmentation, we can come up with an approach that will work well for the African American tweets, also for the European American tweets. Yeah, now coming to bias mitigation. So this is one of the approach like the counter narrative data augmentation that's a standard in community for bias detection for bias mitigation, but it's not always possible to come up with a counter narrative data in large scale. So we have to rely on some kind of algorithmic way to mitigate these biases. So one famous way that everybody uses till date that was released in that same paper of man to computer programmer and woman to homemaker that we discussed in the initial slide of the WEAT metric. So they released two different approaches for devising. One is soft devising and one is hard devising. So how it happens? Let's say you want to devise across gender axis. So you define the gender axis. How do you define the gender axis? You know these are the some gender specific words. He, she, father, mother, brother, sister. These are gender specific words. You get their embeddings and you subtract, let's say, he minus c or c minus c. Similarly for all the pairs like c minus c, mother minus father, sister minus brother. All these gender definition words, you take this vector difference and find the PCA. So obviously the first embedding of the PCA will give you the gender direction. C minus C gender direction. So once you have the gender direction, you project. So now you are in a subspace of this C minus C embedding, right? So in this subspace, you project all of the problematic words and see towards which direction in the word is being projected. So initially, if you see the doctor word being projected on the he side and the northward was being projected on the C side. Now you want to neutralize. So you take that projection on the normal, like the orthogonal component of this he minus. If you understand the nuances of the vector embeddings or the vector spaces, you will easily understand if you project these vectors onto the orthogonal space of this null space of this he c minus e axis. Now the gender component is completely removed. So that was the target. Like we want to remove the gender component, but next target was in the hard devising. Also, those embeddings should be equally close to male and female words, the gender definition words. So in the third step, like first step, you just project into the orthogonal space of this C minus C, then make it equally distance from the gender definition words like father, mother, male, female. So that makes it completely gender neutral. So again, our target was after devising them, whether we're able to achieve the similar, like achieve the analogy task at the same level or not. And they have shown in their paper that even if after devising, the performance of the analogy task doesn't hamper much. Yeah, there are other techniques. Anyway, so there are many techniques from after that paper that have come, but the original idea is only this. Everybody tries to find like particular biased subspace and find the null space, project it to null space, remove the bias component. So here they try to do it through a one-dimensional vector C minus C. So it's not one-dimensional vector. They project it in one-dimensional space. Of course, it is 300-dimensional space. So what people do is like find the gender subspace through different embeddings. Like this was the earlier work was for the what to be. So you do it for like contextual embedding or for the intersectional biases in the contextual embedding. So you find the bias subspace, project it in the null space, and kind of take the projection and kind of subtract to make it meaningful. So that's the a major idea behind how do we do devising till date. There are other approaches. They use regularization concept. So in the regularization concept, what they do, they control how much the meaning of word can have. So the meaning of the semantic space of the word can have meaning for male and female. So if you can control those factors also through regularization, we know the out of 300 embeddings, these embedding space are responsible for defining whether it is male or female. If you regularize those particular subspace of those 300 embeddings, then we can control the meaning of directionality of those words towards male or female also. So that's like kind of a major approach for the bias mitigation. So there are other approaches for bias mitigation using prompting, but I am not covering them because they are a lot fishy. Everywhere prompting is involved, it is fishy only. So you try to prompt it, but you change a single space or a single full stop in the prompting, it doesn't work. So I am not covering them. So but you can just if you are interested, you can check them out. Now something called bias benchmarking data set. So we discussed the matrix. So how much time I have? 15 minutes. Okay. So we discussed the matrix. So the metrics are not enough for like as it is. Like we need to have the quantification through the metric, but that quantification should come from a data set. So those data sets are called bias benchmarking data sets. So we should have some benchmarking data set and combine with some metric, and benchmarking data set and the metric combination will tell us how much bias this model is. Right? There are some famous benchmarking data set like stereo set and crossbear. So if you see the structure of stereo set, what it is. So the scenario is also these benchmarking corpus generally they work for the contextual embeddings. So you provide a context. Girls tend to be more masked than boys, right? And you provide three options to language model: soft, or determined, and fish. So one option like is for stereotypical association, one option is for anti-stereotypical association, one is for unrelated. So unrelated they kept is for a control check to see if the language modeling capability is at all good or not. So if language modeling capability is not good, model might choose option 3 also. So if language modeling capability is good, either they'll choose option 1 or 2 depending on their biasness. If always model prefers the option 1 in either of the not subtasks, then model is more biased. And if it chooses option 2, model is more anti-biased or anti-stereotype. The ideal scenario is if you are testing the model with 100 sentences, similar 100 sentences, 50% of the time it should choose option 1 and 50% of the time it should choose option 2, because we're relying on some decoding strategy that is randomized. Sometimes it might choose option 1 or option 2. If always the randomized decoding strategy chooses option 1, model is biased because the top P probability always gives the highest probability for option, the biased scenario. So similar data set was developed for the name was Crosspair, but there is a little difference here. What they did, they created some paired sentences. One sentence will be biased, one sentence will be anti-biased, or you can say one is stereotype, one is anti-stereotype. And they were checking something called log likelihood of the sentence. If the log likelihood of the sentence, if you know what is the language modeling, we just do the perplexity computation to measure the goodness of the language modeling. That is the log likelihood of the sentence, right? They came up with some variant of the log likelihood that is called pseudo log likelihood. So I am not going to the mathematics of it because that requires understanding of some random variable and fields. So that's much more nuanced because for timing I am not going to that. So they use something called pseudo log likelihood to measure the likelihood of the sentence, but that is pseudo. That's not the exact log likelihood. Forget about that. But that metric shows if the log likelihood, pseudo log likelihood of the stereotype sentence is more, then model is more biased. And if the pseudo log likelihood score of the anti-stereotype sentence is more, model is anti-stereotype, right? So we kind of came up with this was done for like US cohort. We came up with a similar scenario for Indian cohort on Hindi data. And this task is almost similar to the Crosspair, and but done it for Indian cohort in the data with little bit modification to the metric. So feel free to go over this paper also if you are interested, and you will get to know what's the modification in the metric. So now coming to the final part of the today's lecture, case study with machine translation. So as I mentioned, Sarah has covered neural machine translation. I wanted to show you how these models can be biased. These machine translation models can be biased, and what we can do about them. So when I say models are biased, machine translation models are biased. What do we mean by they are biased? This is a classic scenario of gender bias in machine translations. So why this happens? Because of the morphological difference between different languages. What do you mean by morphological difference? If you see the English language, they have the gender association with pronouns. But we don't have gender association with pronouns in Hindi language. We have gender association with verbs or adjectives, right? Sometimes with nouns also. Like some nouns have like kind of gender masculine or feminine words that goes with English also. But specifically, the difference comes here in the use of gender association for verbs and adjectives in Hindi, and gender association with pronouns in English. So, if you see these translations from Hindi to English, there is no gender reference in the Hindi language, but model generated masculine sentence in the generation side, right? Similarly, when we are changing the profession from doctor to nurse, now it is making feminine. So this is happening because, so you can say like intuitively, you can think these translation models are unidirectional, right? It's either encoder, decoder, or decoder only models. If you have some nuance about the transformer architecture. So we the first token itself, when generating the first token, we don't know what is the last token will be, nurse or doctor. From the first token itself, we're kind of towards the subspace of female territory, right? In the embedding space. Why it is happening? Because from the embedding of the Hindi, because first we encode the Hindi sentence and try to generate the English sentence. When we encoded the Hindi sentence, it understood something about the profession discussed in the Hindi sentence itself. There it went to, if we divide the embedding space into two subspace of male and female, it went to that female territory and we started generating like kind of bias sentence from the first token itself in the English side. So if you do reverse thing also, like you make the pronoun or the scenario very neutral in the English sentence and try to translate it to Hindi, you will also see some biased association in the verbs or adjectives of the Hindi. So similar behaviors people have seen in the Spanish language also. This is one example for Spanish language. So this was a task for kind of, this was not original for machine translation. This was like kind of pronoun resolution, like this her is referring to whether the doctor or the nurse here. But if you translate this to Spanish, the way they translate it like inherently is like they understand the pronoun resolution is going from her to her to nurse, even if actually it is going from her to doctor. Right? El doctor is a kind of a male-oriented doctor in Spanish language. So similar behaviors people observed in Bengali language. If you understand Bengali, you can understand this slide. So why this happens? Because the different properties of different languages, the different gender properties. Some languages are genderless languages, some are notional gender, some are grammatically gendered. The most problematic languages are these grammatical gender languages. So they have gender association with many parts of speech of the sentence, many different parts of speech of the sentence. So when you're translating from genderless to, let's say, grammatical gender or grammatical gender to genderless, vice versa scenario. So because model will have one option to make, whether to go towards the male direction or towards the female direction. In particular gender, I am telling you. So it has to make some decision. When it makes some decisions to, if it is biased, it will always make some decision towards one particular group, and the outputs will be biased. So why it happens? Why it makes like kind of tends to kind of prefer always towards one particular gender? It's again because of the fine tuning data or the representation space it has lot, like we saw the representational harm, right? Because of the first, because of the representational harm, whatever representation it has about those gender groups, and second about because of the fine tuning data that we're preparing for the machine translation. So yeah, so the scenario is like why the fine tuning data are becoming biased. So consider a document is consider a document that is being translated manually, and there is no explicit mention of gender for the main character. So if the translator, whoever the human translator, if he is a male person, inherently because of his own inductive bias, he will write those pronouns that is male oriented. If it is he is writing in English, or he'll write those verbs or adjectives that is male oriented. And if you have, let's say, 10 annotators, 8 of them are male and 2 are female, model will of course prefer the like kind of association of male in the, whatever the, even if the context is neutral, right? So how do we tackle this problem? So like always getting equal number of male annotators and female annotators. This is particularly I'm talking about gender bias. So if you go to race bias, religion bias, they are much more problematic because they are multi. It's not just binary now. So how do we tackle this problem? That's like kind of a challenge. So there are some approaches. So always in every context, it's not possible to come up with say annotators with equal gender distribution. So what we can do during annotation itself, we can specify key this token is male oriented, this token is female oriented. So we can say there is a female version of these words or male version of these words, or we can say for every sentence, if there is two possibility of gender association, we can create two possibility of gender association and force the model to learn two possibility. So that in the top P decoding strategy, at least in top one or two, model will have both possibilities. Top one if it is male, top two it will be female. So because of temperature parameter, sometimes it might generate some female oriented sentence, sometimes it might generate male oriented sentence. So that's one approach people use, and another approach is UI-based approach. Again, this works only for the gender bias scenario. It may not work for a race bias or a religion bias. So because gender, we know we are majorly focusing on the binary gender case. You can, if your generation is like grammatical gender language in the generation side, you can generate both feminine translation and masculine translation. So to generate both feminine translation and masculine translation, also model need to understand this token is masculine word or this token is feminine word. For that, this kind of word level tagging or token level tagging for male and female specific words or tokens, that is important. Yeah, so that's kind of the end of the lecture today. So what we discussed is like kind of different sources of bias and definitions, and other things like stereotypes and sensitivity, some initial works of detection and mitigation. So detection, if you need detection through dataset, I have tried to cover the recent works also. For in terms of metric, feel free to ping me if you want to know more about the recent works, or maybe in the teams. What I'll do, I'll share one recent survey paper that very nicely covers everything, detection, metrics, and mitigation. That was published in ACL this year. So you can go through that survey paper. It's 84 per page survey paper, but you can focus on whatever survey area you are interested in. Yeah, so that's it. Thank you. If you